So this lesson is on some kind of cool properties about similar triangles. And we're going to be covering 4 theorems. And I don't expect you to memorize these theorems, but you should have them in your notes and know where to find them when you need them. So these theorems are going to help us to calculate some lengths in some similar triangles. The theorems are the triangle proportionality theorem and its converse. And there's also a corollary to this, which is the two transversal proportionality, and then this triangle bisector theorem. Now, that all sounds very complicated. It's not. Just remember that you don't have to memorize these. They should be in your notes, and you should be able to find them when you need them. All right, so the first theorem we're going to talk about is called the triangle proportionality theorem. And all it says is that if I have a triangle, ABC, there it is, and I draw a line that transverses, that's a transversal to 2 of the sides, and that line happens to be parallel, like you can see EF has the little arrow, and it's parallel to the other side, BC, that this line splits the 2 sides of the triangle into proportional lengths. So AE to EB is going to be the same as AF to FC. So here I drew a little triangle MNO, and I'm going to draw a line that is parallel to NO, and it's going to go through the other 2 sides of the triangle. So let's see how good I can do this. So I'm going to draw a line that's parallel to NO that goes to the other 2 sides. There it is. Now I need to make sure that this looks parallel, so I'm telling you it's parallel, but it didn't look that parallel. So there it is, and it's parallel, so I'm going to mark it with the little arrow. And let's say that I had this ratio. I better name these pieces. So I'm going to call this P and this Q. That's the points where it intersects the other sides. Now, if I knew that this length from N to Q was 2, and this length from M to Q was 5, and then I told you that this length from P to O was 1, I would know that this ratio from 2 to 5 has to be the same, and I don't know what this is, so I'm going to put a little X here. It has to be the same as 1 to X. And so this distance from between N and Q, which is 2, to the MQ, which is 5, is going to be the same as this distance from O to P is to this P to M. And so we can set up this proportion like this, and it's guaranteed to be true by this theorem. And so then I could solve this. I could say, okay, 2x equals 5. X has to be 5 divided by 2. So this length from M to P would have to be 2.5. So this length right here would be 2.5. That's how the theorem works. So the given is that you have to have a line like this that is parallel to one of the sides of the triangle, and it has to cut or transverse the other 2 sides, and then you know that these ratios on this side are going to be the same as the other side. So let's try a problem with that. So here we have a situation, and let's first make sure that we meet the criteria. So I have the triangle RST, and then I have this segment UV, which is parallel to the side ST. And so given that it crosses RS and RT, then I know that it meets the requirements for that theorem. So I know that I can set up a proportion, and I know that this length RU, the ratio to US, is going to be the same as the ratio RV is to VT. And it says find US because I don't know what that is. So let's find US. So I could give it a variable name for that length, but I'm just going to use US. So I'm going to say US over 14. So I started with this length to the 14, so I have to start with the VT to the 10. We could have done it the other way around. So 4 over 10. And then I just need to cross multiply. So this US is going to be 10 times US, whatever that length US is, is going to be 4 times 14. So 4 times 14 is 40 and 16. So that's 56. And then I'm going to divide by 10. And this length US is going to be 5.6. And we don't have any units for that. So this length right here is 5.6. And that's how you will use that theorem. The converse of that theorem, of course, converse means we go in the reverse direction, right? So the other theorem, the triangle proportionality theorem, says that if I have that parallel line that transverses that triangle, it's parallel to one of the other sides, then I'm going to have the proportion. So the converse says that if that proportion is true, then I can show that that line is parallel to the third side. And so here we have a triangle ABC, and it shows me that this line transverses the other two sides, and I want to show that it is parallel to BC. Well, I can do that if I can show that that ratio holds, that the ratio of this EB to AE is going to be the same as CF to AF. So here I have a triangle that's looks like that situation. So I have triangle XYZ, and I have these side lengths here. So I have, I guess I'm going to call this M and P where it crosses. So I've got this length from M to Y is 3, the length from M to X is 4, and the length from Y to P is 5, and the length from P to Z is 7. So I want to see, is that line parallel? So is this line that I drew from M to P, is that transversal? Is it parallel to XZ? Well, if it is, if the ratio is the same, it's going to be parallel. So I'm going to say 3 to 4 equals, I don't know if it's equal or not, 5 to 7. And so when I cross multiply here, I should get these same values. I can already see that it's not the same. This would be 21, this would be 20, right? 3/4 is not equal to 5/7. Well, what did that tell me? That tells me that this line that I drew here is not parallel. Okay? If these were the same, that would mean that this line segment is parallel to XZ. And obviously it's not the same. 3/4 is not 5/7. And so the conclusion that I have is that this line is not parallel to XZ. So here's an example, and it's that situation that we just described. And it says verify that DE is parallel to BC. So show that DE is parallel to BC. When it says verify, you can assume that it's true, and you're supposed to just show that it's true. But let's see if it is. So I'm going to look at the two transversals. So I want to see that DE is parallel to BC. So I'm going to look at these ratios from AD to DB, from AE to EC. And if I set up that ratio, it's going to be 10 over 15. Could have did 15 over 10, but I didn't. And I don't know if these are equal, so I'm going to put a question mark here. And 8 over 12. And I'm going to reduce these fractions to see if they're the same. So I know that 5 goes into 10 twice, 5 goes into 15 3 times. So I get a fraction of 2/3. So when I reduce this 8 over 12, it should give me 2/3, if in fact those lines are parallel. So 4 goes into 8, it goes in there twice, 4 goes into 12 3 times. And you see I get the same ratio. Based on the converse theorem, I can say that these two line segments are parallel. So this line DE is parallel to BC. And our reasoning is by the converse of the triangle proportionality theorem. Again, I don't really care if you know. I mean, if you remember the name. What I want you to understand is what it tells you. So the last example is called the two transversal proportionality. And again, you don't have to memorize that. But here's what it says. It says that if I have two lines, and you notice these lines are not parallel, but they're cut by a series of transversals that are parallel. So I have these 3 lines that are parallel to each other, cutting these lines here. And what it says is that if these lines are parallel, then they break up these lines they're transversing in proportional pieces. And it says 3 or more, so you could have 100 of them. It doesn't matter how many. So here I have that situation that's described. I have these two black lines, and they are cut by 3 blue lines that are parallel and transversing them. So let's say, and I'm just going to make these numbers up, but let's say that I have this length right here is 1, and this length is 5. And I know that this length over here is 8, and I don't know this length right here. Well, the theorem that we just talked about guarantees that these lengths are in proportion. So if I take the x and relate it, it's the same relationship to 8 as the 1 has to the length 5. And so if I want to find out what x is, I can just cross multiply. And so x is going to be 8 divided by 5. So 8 goes into 5, let's see, one time. And then I have 3. And so 3.0, that would be 30. So this is going to be 1.6. So this length right here, x, would be 1.6 based upon the theorem that we used, because the theorem told us that those lengths had to be proportional, and based on the fact that this length was 1, this length was 5, and this length was 8, I could calculate the new length, which was the 1.6. Okay, so here's an application where we can use that theorem. You can see it's an art application. So here's a picture, and we can see that in this picture we have 4 parallel trees. And we also have these transversal. One is kind of the line that marks the height of the trees, and the other is the line that goes around along the ground. And so we want to find these lengths. So we know the line that marks the height of the trees. We can see the distance between each tree on that line is 4.5 inches, 2.6 inches, 4.1 inches. But on the bottom, those lengths on the bottom, we can see that the length from K to L is 4.9, but we don't know L to M, and we don't know M to N. But we can find it using that theorem, and that's what they want us to do. So what that theorem says is that this length LK to LM is going to be the same ratio as 4.5 is to 2.6. So let's set up that ratio first. So I'm going to say 4.5 to 2.6 is going to be the same as if I did 4.9 to LM, right? So that'll find this first distance that we need to find. And so I'm going to cross multiply, and cross multiplying, we will see that we get LM times 4.5 equals 4.9 times 2.6. And then I'm going to divide by 4.5. So the length LM is going to be 4.9 times 2.6 divided by 4.5. And I'll calculate that out. And once we have this length LM, then I'm going to be able to do the next section, because I'm going to be able to say that the length 2.6 is to 4.1, the same as LM is to MN. So let's calculate this. And the answer I get is 2.83. And it says to do it to the nearest tenth. So this is LM equals 2.8. So we have 2.8. And so then we can set up the next section. And so I'm going to say 2.6 is to 4.1. So 2.6 is to 4.1. The same as 2.8 is to MN. This last bit that we need to find. And so again, I just cross multiply and solve. And so doing the cross multiplication, I will see that I'm going to have MN is equal to 2.8 times 4.1 divided by 2.6. And again, I'm going to round to the nearest 10. And this works out to be, MN is going to be 4.41 And so we're rounding the nearest tenth, so it's going to be 4.4 inches. And so this would be 4.4. We have one more theorem to talk about. This is kind of a neat one. It's called the angle bisector, the triangle angle bisector theorem. And it just says that if I have a triangle and I bisect one of the angles, that when that ray that bisects the angle hits the other side of the triangle, that it splits it into two parts that are proportional in the same way to the other two sides of the triangle. So this length BD to DC is going to be the same ratio as AB to AC. So let me set up an example. So here we have triangle MNO. So we have triangle MNO, and angle N is bisected by this segment NP. And so bisecting means that this angle MNP is going to be congruent to ONP. And what this theorem says is that the relationship between the two sides, this length 10 and this length 14, is going to be the same relationship that these two segments have that are split on the third side. So we can set up a little proportion. So I can say 10 is to 14. So 10 is to 14. That's the relationship between the two sides of the triangle. The same as 8 is to x, and that's the relationship between the two parts of the third side that have been split. And so then we just have to calculate the proportion there. So I'll have 10x is going to be, what is 8 times 14? That's 80, and 32. So that's 112. And then I'm going to divide by 10. And so this new length, this length peak O, is going to be 11.2. So that would mean this length is 11.2. And that's how you would use that theorem. So let's do an example. And so using the triangle angle bisector theorem, and they want us to find the lengths PS and SR. So here we have it, and we know we can identify here's the angle that's bisected. So I'm going to use the highlighter to kind of highlight some things. So here's the two sides of the triangle, and then we're going to have these two segments that are cut. So I just need to set up the proportions. So I'm going to start over here with the 40. So I'm going to say 40 is to 32 as, and if I started with the 40 here, then I need to go with this part, the x plus 5 next. So then I'm going to say, okay, 40 is to 32 as x plus 5 is to x minus 2. And then we're going to solve this using cross multiplication. And so we have 40 times x minus 2. Remember, I need parentheses because this is a quantity that I have to treat as a single number. It's both parts are multiplied by 40, so I'm going to use parentheses. And that's equal to, and similarly 32 is going to be multiplied by the quantity, so parentheses, x plus 5. And then we just have to distribute and simplify. So I have 40 times x, that's 40x, and then 40 times minus 2, which is minus 80, and that's going to be equal to 32 times x and 32 times 5. And so 32 times 5, that would be 150 and 10 more, so that would be 160. And so we just subtract from both sides. So I'm going to subtract 32 minus 32. So over here we will have 8x, and this will be, I'm subtracting 32x, not 32. And then I'm going to add 80 to both sides. So plus 80, plus 80. And so we have 160 and 80, so that would be 240. And then I'm going to divide by 8. And 24 divided by 8 is 3, so x is going to be 30. So there we go. So x is 30. And don't forget, I don't want to stop now because that really wasn't the question, right? They didn't say what is x. They said find PS and SR. So I have to take that 30 and then I'm going to plug it in here and find PS. So PS is 30 minus 2. So PS is 28, right? This is 28. And then 30 plus X, or sorry, 30 plus 5 is going to be SR. So this is going to be 35. And there's our answer.